Hi everyone, my name is Lars Kroll. I'm a PhD student at KTH and a teaching assistant for this course on distributed algorithms. During this course, you will have to complete a number of programming assignments, and these assignments will have to be done in the Scala language using the complex component framework. To complete the assignments, you will also have to use a Zeppelin-based environment that we provide to you for the course in form of a virtual machine image. If you haven't downloaded that image yet, I recommend to pause the video here and do that now. With that out of the way, let me begin by introducing the complex component module. Basically, complex is a framework for building distributed systems. And the API as it stands today is inspired by this book, which is the course book. And what we want to do is we want to compose protocols from components, and we want these components to be reusable, so we can compose them into different protocols. And we want them to execute concurrently. And they are supposed to react to incoming events. And these events should be the only way of communicating between components. And this is also referred to as message passing concurrency. Additionally, everything in complex is typed. Port types, for example, form the external interfaces of components. And instances of port types are called ports. Now I will go later into more detail upon port types, but for now it's sufficient for you to know that they basically define an API by specifying which way certain events can go across ports. Remember, ports are instances of port types. And such instances are created on components by either providing or requiring a port type. As is shown here in the example, by having the port either on the bottom, like here, now this would be a required port, or at the top, like here, this would be a provided port. The ports themselves are connected by bidirectional channels, which are also typed with the type of the port. All right, so this arrow here is a channel. And channels simply forward events in FIFO order with exactly one's semantics. Now, I said exactly one's semantics, but it is possible and actually quite common to connect multiple channels to a single port, in which case all the events coming out of that port would be broadcasted across all the connected channels, but still per channel we have FIFO exactly one's semantics. Let us now look at the more internal view of a component. Components can have multiple ports of either type, provided and required. In this example you can see two provided ports. And components also have internal state. Components have exclusive access to their internal state without the need for any synchronization. Now, to interact with that state, components have to process events, and the incoming events are processed by the handlers that match them. And in complex Scala, which is what you're going to use for the course, this matching happens via Scala's pattern matching facilities. However, before any matching happens, a handler must be subscribed to a port to receive events. Now, this view is enough for us to look at a short and simple code example, and we will come back to the theory afterwards. Here you can see the Zeppelin environment I alluded to earlier, and I hope you have the virtual machine image installed by now. We will proceed this tutorial by writing a simple Hello World example in complex. Now, there's one thing I would like you to know, that complex is actually a Java framework at the core, and the Scala DSL we're using in the course is just a thin layer, relatively thin layer on top. That means you will see occasionally some slight Javaisms, but don't worry about it. I'll point them out when we get to them. Now, to start, we simply import the Scala DSL, like so, where the last part with the SL is for the Scala version, the part before that is the Java version. And you don't have to worry about any dependencies, they're already included in the VM image we've given you. And now I've told you that in complex everything happens in components. So to write our Hello World example, we will write a very simple component And in the Scala DSL, as well as in the Java version, a component is simply a class. And we end it in C typically to show that it's a component, just a convention, you don't have to do that. And that class has to extend component definition. Now, in this very simple example, we are neither requiring nor providing any ports, but we do need to know when we want to print our hello world. And the way we're going to do this is we are going to use one of the lifecycle events of compix. And that event is called start. And as the name suggests, it's triggered when a component is started. And it will be triggered on a port that is called the control port. And every component automatically has a control port. You never have to provide or require it. And in the Scala DSL, the control port is simply called ctrl, like the key command. And to write a handler on this port, we write upon event. And in this block, we can simply pattern match on any kind of incoming event to tell compix which events this component wants to handle. And the event we want to handle is the start event. Now, I told you the start event is one of the basic events, but it also means it's one of the events that are coming from the Java side of things. So we have to have a separate import for it. And since we're going to need more from this package, I'm going to import it like this for now. Please do not just wildcard import everything from compix, because you will end up with name clashes with a lot of things in the Scala DSL that have the same names and redefine the functionality in a slightly different way. You'd have to rename a lot of things. So just do it like this. It's not so many things you usually need from the Java side. Okay, and now we can simply pattern match against this class, and then to actually execute the handler code, we write handle and then start a new block. Now note that you can write any kind of pattern matching code that Scala allows in the upon event block. However, that part of the code is not executed in such a way that you have access to the component definition state, at least not exclusive access. So please don't access any mutable state from any guards within pattern matching statements. As soon as we get into the handle block, you can access state and you're guaranteed that you have exclusive access to it. In this case, we don't actually need any state. All we want to do is simply print hello world. And now, if we were to run this, we wouldn't actually see anything, and in fact, our VM would never stop running. Because compix is an environment for building distributed systems. Distributed systems typically just keep running until they're manually stopped. They don't just execute some code and then finish. So we have to stop it manually, and the way to do this is we write compix and we do async shutdown, which means don't block the component. And this is how you do it from within a component. From outside a component, you can simply write compix shutdown. And compix is once again one of the Java things, so we import it separately. Now we can ask the Zeppelin interpreter to compile this and store the things we defined by either pressing this arrow or, as you can see there, simply doing Shift-Enter, which is what I'm doing now. And you will see that it imported the two things and it defined the class we asked it about. Now, to actually run this, we need to do one more thing. We need to define which component is supposed to be started by the compix environment when it starts up and actually start that environment. And for that, we also use the compix object we imported up there. And we write compix create and start. And then we give it a class of some kind of component definition that extends component definition, like our hello world. And that's it. Now, if we run this in the same way, we see hello world as expected. Now, this example was very simple. We'll get to a more complicated and interesting example later, but first I have to talk to you again about more details on ports and port types.